Determination of particle size by dynamic light scattering, DLS. Dynamic light scattering, DLS, is a non-invasive technique that detects the fluctuations of the scattering intensity due to the Brownian motion of particles in a fluid. DLS can be used to determine particle size, size distribution, and relaxation in complex fluids. DLS is particularly suited to measure particles in the nanometer size range. In a typical light scattering experiment, the intensity of scattered light is measured at a certain scattering angle that can be associated to a scattering vector Q. In particular, a dynamic light scattering spectrometer measures the fluctuations of scattering intensity with time. These fluctuations can be converted into an autocorrelation function. A decay constant can be estimated from curve fitting, and then a diffusion coefficient can be calculated. Using the Stokes-Einstein equation, the hydrodynamic diameter or size can be calculated from the diffusion coefficient. This is the diameter of an ideal sphere that diffuses at the same speed as the particle or molecule being measured. Ideally, light is only scattered in one scattering event, but this only occurs in very dilute samples. At higher concentrations, multiple scattering takes place, as light is scattered in several scattering events. Multiple scattering increases with concentration. Sample dilution may change effective particle size due to changes in colloidal stability, structure, and surface charge. The concentration range in conventional light scattering instruments is limited. The 3D cross-correlation technology enables to expand the concentration range of samples that can be measured. In the cross-correlation technology, two monochromatic and coherent laser beams are focused in a test sample. The overlap of the two laser beams forms the scattering volume. Light scattered by the particles is detected at a fixed angle by two detectors. Thus, two independent scattering measurements are performed at the same scattering volume. This allows the identification of multiple scattering so that this effect can be removed for improved data analysis. DLS data can be analyzed in different ways. The Cumulant's analysis method gives a mean particle size and an estimate of the width of the distribution, polydispersity index. A monomodal size distribution is assumed. The CONTIN analysis method allows to fit the data of multimodal samples, resulting in a size distribution function. For more information, visit us at iqac.csic.es/qci/.